As I was saying before, I interrupted by technical difficulties. Let me share my screen for the central limit theorem at this time. And we're talking about groups of people or objects and their mean being within a certain amount. So you'll see that the formula is very similar. Mean of a sample mean. And we have a formula that looks like this. So z is equal to z of x bar, where x bar is minus mu of x bar over sigma of x bar. Very similar. The thing about sigma of x bar is that we have to then divide by, and there are things to pay attention to, because you have to have a minimum sample size calculation, okay, in order for this to work, or it won't assume a normal distribution, won't assume the shape that you won't have it. So pay attention to these assumptions on slide 6. Now, when you go to do the calculation, it's very similar to the first. Let me go back. What is the probability or likelihood that 1/8 grader selected at random will score below 375 on an exam? So here you're a high school principal and you want to know that what is the likelihood of one particular person, and then in C it says a group of 100 will have a mean below that. So what we're doing here, part B was what you did in 6.2. This part C is your new concept for the section. And she goes through and shows you here what happens for each one of these. So you want to pay attention to whether you're doing one person or a group of people, okay? Because there is a change in the formula. And that's basically what it is for 6.3. Now, the last thing you're going to be doing this week is the central limit theorem for sample proportions. And that works sort of the same in theory in terms of doing more than one score, but the formula is completely different. And the homework is not in your textbook. The homework will be on Canvas, and we will post a key, not full solutions, but we will post a key for that particular section of material. We will make the full solutions available to you after the work is turned in, so you can see, but you will have a chance to see how it works. And we do have some extensive examples in the PowerPoints. So I'm going to stop sharing, and I'm going to share my other application as soon as it opens, so we can review central limit term for sample proportions. You want to make sure that you pay particular attention to the definitions and assumptions. The assumptions make a big difference here, and you will be tested on the assumptions, okay? So it talks a little bit about the proportions to start, talks a little bit about the notation, and then we take you through some examples of how the notation works and some definitions of it, okay? The central limit theorem for sample proportions, the actual theorem itself rather, shows up on slide 10. The mean, as you can see, is P, I'm sorry, and the standard deviation is the square root of P times Q over N. Okay, so you're going to see that she takes you through this statement. She takes you through working out the material. Um, and then she takes you through finding it on your calculator. So you do have a problem that's fully worked out, just like the homework. So pay attention. This example starts on slide 14. Suppose that 75% of Concordia students like corn on the cob. An SRS, that's a simple random sample, of 45 students were selected to determine whether or not they like corn on the cob. Are the conditions necessary to apply the CLT satisfied? Explain. She's going to test on the assumptions. The assumptions are on the slides. Make sure you study them. You will have to write out the assumptions. So she shows you how that works. She shows you how you test this particular thing. She also shows you how to calculate the probability that she's asking for. But do read the instructions. There are a couple of really good examples in here, and the homework will give you lots of practice. So that's about all I have for now. I hope that this video is helpful to you in your study and as you go through the sections for this week. I hope that you are safe and I hope that you're healthy wherever you are. And I look forward to seeing you in the next video. Take care, everyone. Thank you very much. We'll talk to you later. Bye for now.